Hello everyone, how are you? This video is about computer coding or computer programming, which is very simply telling computers what to do. There are many different ways to do this, and of course this short video will look at only the most basic ideas. So as I said, coding is how we give computers instructions. That's how we talk to computers in many ways. Computers think using just two things. Do you know what those things are? I'll tell you, they are zeros and ones. Everything inside your computer, when you get right down to it, is made of just zeros and ones. Numbers using just two digits, and this is a system called binary. It's a way of counting with only two digits, and it's the simplest way of coding information. But humans can't do this, so to communicate with computers, we need a language. And actually, we have many languages. So as a side note, I want to talk about layers of abstraction. Everything we do with computers is an abstraction. Humans cannot think using zeros and ones. They are not transistors and electrical devices. The way computers work does not make sense to us. And so we must create models and languages to help us understand what computers are doing. Programming languages are part of this process. So, do you speak computer? There are many different coding languages like Python, Visual Basic, C, C++, PHP, Ruby, and others, and even web functions like HTML and CSS. All of these are different languages for coding different things on your computer. And the word language is not a joke. All languages have their own grammar and vocabulary, and computer languages are no different. If you speak one language, for example Python, it doesn't mean that you can speak C++. Of course, many of the languages have similar forms. There's a lot of mathematics in all of them, but all computer programming languages have their own ways of doing things, and you need to learn them as a different language. This means that learning a computer language is just like learning a normal language with more maths. The next thing we'll talk about are programs. Programs are pieces of code designed to do something. There is a more mathematical word for what we might think of as programs, and this word is algorithm. Now, there might be some subtle differences in the way we use the word program and the way we use the word algorithm. But programs and algorithms are pieces of code designed to give a certain result when you put in information. Programs on our computers are series of instructions that tell computers what to do, whether that program is a utility like Office or Word, whether it's a game or whether it's a web browser. The program is a set of instructions to tell your computer how to show you the information that you want to see. But if you want your program to work, then you must communicate clearly with the computer. And that's just like real people when you think about it. Another quick side note, when you talk about programming or look at websites, you sometimes see the word shell and environment used. Both of these words basically mean the program space. For example, you cannot just open Microsoft Word and start typing in Python code. Well, you can, but it won't work as computer code unless you are in a Python environment. So you can think of everything happening inside your computer as a space. And that space is filled with lots of things. Your operating system, like Windows, is taking up some of that space, and that's doing things in the background. And when you want to do something with a programming language, you're going to need to open another space in your computer, and this is where you will do your coding. And this space is an environment for your code. So if you're going to do Python code, then this is called a Python environment. And the border around this environment you could think of as the shell. So a Python environment or a Python shell is a space in your computer where Python code can work. And the same is true for other computer languages. So let's look at a few types of object that you might see in programming languages. First, you might see integers, and here are a few examples of integers. Do you know what I mean by an integer from these examples? You might also see floating point numbers. Here are a few examples of floating point numbers. Can you tell me what a floating point number is? And finally, strings. These are some examples of strings. You might think you know what a string is in the everyday world, but what is it in a computing context? These are all examples of strings. So, do you have a clear idea in your head? I'll tell you now that integers are whole numbers, numbers that are made of just multiples of 1. Floating point numbers is what we call decimal numbers. These can be parts of numbers, the ways of writing fractions as a decimal, or whole numbers just expressed as a floating point. 1.0 is a floating point number, even though it's the same as the integer 1 in terms of value. Finally, strings are sets of characters like a line of text. So if you just want to take and reprint a line of text, you will type that text as a string. So those are some types of object you will find in a programming language. Now let's look at some actions, and we're going to come a little bit closer to the Python environment, which is where future videos will go, but other languages work in broadly the same way. You might need to learn a little bit of different vocabulary. Python has commands, it has variables, and it also has operators and some other things, but that's where we will start. Pause the video for a moment and think about what you think these mean in a computer program. Try and put it into words if you can. I will now go on and tell you that a command tells the program to do something. It's literally something that you can say, do this, like print or open or run. A variable is a piece of information, something that the program can remember and use, something that we hold in the program, and then when the program needs it, it can say, what is that variable? Oh, that variable is whatever. And then operators are like maths operators. They might literally be maths operators, or they might be some other kind of logical operation. But there are many new ways to use operators in programming languages, as we will see next time. And just before we finish, I would like to take a moment to go through the simplest possible Python program. It's a one-line program. So this is our one line. And the program will look something a little bit like this. Print hello world. And that is our code. So this is a one-line piece of code that will print hello world. And here we have print, which is the command. And then the print command will put what it's going to print in brackets, and the thing that we want to print is hello world. So this is a string that we want to print. Hello world is a famous bit of coding history. Apparently, when the first programming languages were being designed, one of the universities that was designing them used this as one of its test cases. When you type a programming language, the shell that you are using will often automatically color commands in, for example, blue or strings in purple. This can change in different shell programs. So as long as you are using one shell program, you can learn how the program is going to color your commands. So this is a simple program. When you run this program or execute this program, then in the output shell of Python, you're just going to get hello world. And you'll notice that it doesn't print the quote marks on that. It just prints the text string that we entered. So, like I say, this is the simplest possible program in Python. But just in case it doesn't make sense to you, let's try and lay it out as a flowchart. If you've seen our previous video on flowcharts, then hopefully this will make it a little bit clearer. So a flowchart will start with an oval, and this is going to be start the print program. Start the print program, okay? And I'm going to just draw the arrows in whatever color I am using here. But we do need to change color for the next object. And the print program needs something to print, and that means we need to input something to the computer. An input is a parallelogram, and this is input the print command. I won't write all of command. Okay, and then you will put the string into that command. Okay, after that, what do you need to do? Well, you're going to run your code. So we could leave that as given, but let's make it into a process. Run the code. Sometimes you see the word execute as something we do with code. If you're used to execute meaning to kill someone, well, execute means to do something in a computer, and it kind of works in a one-way direction. So when you kill someone by executing them, that's something pretty one-way, I guess you could say. Okay, and so after we run our code, what are we going to get? Well, we're going to get the output of our code. And the output of our code is this up here. This is the output of our string. So output string. Okay, and that is the end of our code. We only have one line in our code, so we can now go to end our code with another oval. So this is end print. So there you are, the simplest possible line of Python code. And how can you break it down into a flowchart? Now, I'm sure you can see that the flowchart here is much more effort than just writing the program itself. And of course, for simple programs, that might be true. But you can also see how by using the flowchart, we are breaking our program down into a list of things and the order that they happen in. And this is why flowcharts are useful for helping to plan your computer code. Thank you for watching.